This is tutorial question number 3. Determine the magnitude of the horizontal and vertical component of the force per unit length of the water on the concrete seawall of figure 3. So here in this question, they use the idea of per unit length here. So per unit length means all the answer need to be divided by the length here. So, to simplify this calculation, you may assume that when you have a per unit length word in your question, you could imagine that the width is equal to 1 meter. So means you just assume that the width is 1 meter. So, and then you could proceed your calculation as usual. So in this diagram, we know that we need to calculate the force on the curved surface here, but this curved surface is not circular shape. It is not a semicircular or quarter circle shape. So it is a shape that constructs from the special equation. So in this question is y equal to x squared. So means we need to solve this based on this equation. So and then from this diagram, we know that the depth of the water here is 8 meter, and then the 6 meter here, please be very careful because this 6 meter is not the length from this point. So we need to calculate what is the distance from the origin here, from the 0 point here to the point where the free surface intersect with the curved surface. Okay, we could solve this problem by assuming the curved surface as a curved graph. So means that if we have a graph with a y equal to 2x squared, so if the value of y here is 8, so means that we could substitute into this equation and then we could get it is equal to 2. So means now the horizontal width here is 2 meter and the height here is 8 meter. In this problem, per unit length means all the answer need to be divided with width, or you may assume the width is unity, means the width is equal to 1 unit. First, we could calculate the horizontal force. The equation is rho GHCA, and then we could get it is equal to 313.9 kilonewton. So in this situation, what you need to do is you just imagine the projection area of this curved surface. So means that it will become a vertical plane like this one. So and then because the depth is 8 meter, so we could this is the centroid, and the centroid will become 8 divided by 2. And then we could assume the horizontal force will act a little bit lower from this centroid. So and then the calculation of horizontal force is like this one. And then we could calculate the YR based on this equation. So we get it is equal to 5.33 meter. So and then we could calculate the vertical force. The equation is remain the same, is rho g volume. However, in this situation, we need calculate the volume above the curved surface. So mean we need to calculate the volume of this one, because of this surface is not it's not a semicircle. So we need to calculate by using the idea of this one. So we need to calculate the volume here by deducting the rectangular area. Okay, the rectangular area with the area under the curve. So we have the area under the curve like this one. So it will give us the area above the curve. Okay, so you may calculate the area under the curve by using your previous knowledge of integral method to calculate the area under the curve line. So please make revision on this topic. So and then if you do this, okay, you will have the integration of 0 0 to 2 y dx. So and then we need to replace the value of y here, okay, because we need to integrate it with dx, so it is equal to 2x square. So and then the limit is 0 to 2 because the integration is on x-axis. So and then we could get that the delta v, the delta volume here, means the volume above the curve line here is equal to 10.67. So and then we need to calculate the point where the vertical force acts. It is the centroid of the curve area. However, it is not common and symmetrical shape, so we need to make an integral calculation. So we assume that we have a line here. So and then with the idea of moment, so we have, let's say we have total force of total vertical force of Fv here, and it is act on a distance of xr. So and then we could assume that there are so many small rectangular area like this in this curved surface. So let's say we take the rectangular area like this one, the first one. We assume that because it is very thin, so the thickness here will become dy. So and then we could calculate the vertical force of this rectangular thin area, small area here, as Vf1, and it will act on x over 2. Why? Because we assume that this total length is x. So and then it will pass through the centroid. So the centroid means the center point of the x, so we assume it is equal to x over 2. So and then we could write a calculation like this one, means that the total vertical force times the xr, so it is equal to vertical force for only one rectangular area plus the location of the centroid, so which is the x over 2. So and then to determine or to calculate the vertical force, so we use the equation of rho g volume. So the volume for the curve, the volume above the curve line is 10.67. So we already calculate this value. And then to calculate the vertical force for the rectangular area, so it is rho gv, it's still rho g volume. So we have a rho g here. So and then the volume, the width is 1, and the area is x times dy. So x times dy means the area is x here times dy and times 1 as the width. So and then we could calculate this equation. Okay, so here we will do integration in terms of dy. However, our equation is in x. So we replace, because we know y is equal to x squared. So from this equation, we could change. So we could know that the x squared here is equal to y is 2y. So and then we substitute into this one. So we could get it is equal to y over 4. So we do the integration from 0 to 8, so we get it is equal to 8. So and then we could calculate the value of xr here, xr there, by dividing 8 with 10.67, so we could get it is equal 0.75 from the axis. So please bear in mind in this curve, because it is not circular, so there are no center of circle here, because the curve is not a circle. So and then we could calculate the resultant force, or we could draw the diagram of the force like this one. So we have the vertical force like this, so and then we have the horizontal force like this. So and then the combination of vertical and horizontal force will give us the resultant force like this one. And then we could determine the angle of the resultant force by calculating the tangent here. By calculating the tangent, so we could get the angle is 18.44 degree. So the angle is in this point.